Mobile Source Air Toxics Risk Assessment course. We're going to cover emissions inventory. We need to understand emissions inventory in general, driving cycles, how emissions inventory works for mobile sources, what are the input data and what are the models, and we have a quick overview of MOVES 2014 from the US EPA. What is emissions inventory? It is basically the process to estimate emissions from sources that emit to the atmosphere. We will overview now in general emissions inventory for all source types. And here they are. We have area sources, we have point sources from stacks such as this one, another point source. We have on-road mobile sources. This is the focus of the course, but we also have non-road mobile sources. When we do emissions inventory, we need to understand what pollutant types we are assessing. It is common that we cover the 6 criteria pollutants. These are the carbon monoxide, nitrogen oxides, sulfur oxides, PM, both PM10 and PM2.5, ammonium, and VOC. However, there is a common list also from the US EPA of 188 hazardous air pollutants. We can also do emissions inventory in over thousands of chemicals, but this is the most common way of executing emissions inventory. Here are the source categories that we saw previously. We have point sources, which are stationary, and we will divide point sources into major point sources, stationary sources, and minor ones. We also will have area sources. These could be any type of source. Could be small point sources, or it could be things that are not point sources at all. If you have gas stations, they emit, but they do not emit like a stack. But they are smaller than large power plants, so they will be considered to be non-point source, and these examples are for area source types. Now, our focus is on-road mobile sources. So in this course, when we refer to mobile sources, we mean on-road mobile sources. There are also non-road mobile sources. These could be airplanes, large ships, and some other equipment. And here we have the major sources represented by the point source, and they're going to be called major if the source emits more than 10 tons of any one of the HAPs, or more than 25 tons of a combination of HAP. Now, if a source also emits 100 tons of SO2, that source is considered to be a major source. Distinguishing this is important because regulations apply differently to major sources than they do to minor sources. Now, non-point sources, or in general, area sources, they will include small sources that have contributions to the pollution, but they are much smaller than the large major sources. And these include gasoline stations, bakeries, dry cleaners, etc. Now, this is our focus for mobile sources. First, on the on-road, it is common that we will address 20 main volatile organic compounds, and we will always address diesel and PM exhaust. Non-road types, they are the ones that are not usually used on roads. It can include your lawnmower, locomotives, aircrafts, commercial marine vessels. These are the large ships that usually burn fairly toxic fuels. We can address those. The techniques that we are presenting to you for the dispersion model, for the human health risk assessment, ecological risk assessment, and Monte Carlo approaches to handle uncertainties, they apply also to non-road mobile sources. But we are presently going to focus once more on road, not non-road. And here is a very important explanation when you're doing emissions inventory. And what happened is this. When we start an emissions inventory, it doesn't matter if I study here in Canada, anywhere in the United States, we have done dozens of those. We have done emissions inventory, complete emissions inventory for complete states and complete countries. No matter where you do it, there will always be lack of information. Do not measure directly every single emission point and every single diffused emission from a gas station. So since we're not measuring, we must estimate. And the best thing to do is to actually measure. And you will see here at the top, this is continuous emissions monitoring. I started doing the best reliability of the estimate for the emissions inventory. However, if you look and see here in this axis, as you progress upwards, the cost increases significantly. And as you move on this, the reliability of your estimate for the emission also increases. So we have engineering judgment. We have the famous US EPA AP42 estimates, and they have rankings from E, which is the worst, and it goes all the way to A, which is the best. So some of the methods that were developed apply to such a broad category of emitters that it's not very reliable. Each one of the emitter types will have different reliability on the results. So if you are very specific to a process, the reliability will go to A. If it is more generic, it will stay on the E. We also have state and industry factors. These were measurements either done by a state, a regulatory agency, or by industry themselves. American Petroleum Institute did a lot of these emissions inventory, and they measured, calculated, and produced better emissions factors than AP42. We progress here into material balance, single source test. If we cannot test all the sources, but we test 1, 2, 3, we start improving our results. And we go all the way to continuous emissions monitoring. If we could monitor everything with this, it would be great, but it's not possible. We would have millions of sources to be monitoring continuously, 24 hours a day, 7 days a week. That's not reality allows us to do at present technology. And as you can see, this is uncertainty when we do the first step in an emissions inventory. And as we progress, we're going to reduce the uncertainty because we will not have a lot of data. So we need to use judgment of what they are. And as we get more and more data, for example, what is the actual consumption of fuel oil in a boiler, that improves our estimates. And then when we say what is the actual fuel composition of this fuel oil in that boiler, we improve it further. So with time, we expect this behavior uncertainty reducing as time goes by, as long as we have an effective continuous improvement program in place to advance our emissions inventory and get better estimates. This is the brief introduction to generical view of emissions inventories. And if you have questions, feel free to email these questions to me.